네, 그럼 바로 시작하도록 하겠습니다. Okay. I'm Hyunwoo Ha and I'm PhD student in AMIREP. So today I'm gonna cover SVDiff, compact parameter space for diffusion fine-tuning. So this paper is about the personalization task on image diffusion, text-to-image diffusion models. So why I choose this paper is that I have already experienced one of the paper which tackles this task, which is named Dream Boost. So when I have experiments with these Dream Boost, I have found some limitations, and the SVDiff actually said that they tackle these limitations. So I choose this paper to know how they tackle these limitations. Okay, contents are like this: motivation, preliminary steps and method, experiments, and conclusion. So, as Sungbin said, maybe all you guys know that the text-to-image diffusion model have great success. Like this is stable diffusion. Sungbin said these are latent diffusion models. So the many research directions are followed by this great success. So one of the tasks is like this. This task is personalization. So suppose that we have a few images that share a one concept or one subject. Then what we want to do is fine-tune the model by these images. And using this diffusion model, we want to generate the images, but conditioned by the personalization on this set of images, which shares same concept. So this is the task definition. So there are challenges. The first one is large parameter space. For example, in Dream Boost, when we fine-tune the diffusion model by the images, the parameter space is actually the total parameter of the model. So total parameter of the unit actually. So in this case, this takes inefficiently large model storage, and the other side effect is that when overfitting to the few images, but has large parameter space, then it shows the language drift phenomenon. So this problem is not so good. So they want to tackle this challenge. I will explain this in preliminary. The second thing is that, okay, I say the personalization, but how about we generate multiple personalized concepts in one image? Then in this case, the limitation is that the multiple concepts are stitched or mixed unintentionally. So this is the problem. This paper tackles by two methods. So one solution is that, so we have large parameter space, then how about we just make compact parameter space by singular value decomposition technique? So this is solution one. And solution two is they propose the common mix or mixed data augmentation technique. Actually, very simple technique, but they said by doing this, they prevent the multiple personalized concepts are unintentionally mixed. So separate the concepts is tackled by this augmentation technique. Okay. So preliminary begins with diffusion models, but it does not require the deep understanding, so I will quickly move on. So diffusion models, it has four process. Four process has add noise, noise, and noise, and to the Gaussian noise. And backward process means we want to force our model to predict the noise in forward process. So this slide is from Gon Kim. thanks to Gon Kim. Okay, so actually training of diffusion models has some details, but we do not have to understand the details, but just look at this red box. And this red box means training objective, and this is epsilon I, which we want to predict, and this is epsilon sierra, which is our prediction by our model. So this is all. Move on, stable diffusion. So stable diffusion, as well as Sangbin said, this is a conditioned diffusion model. So when we choose the text input as condition, then it becomes text-to-image diffusion models. So the one difference is that in loss function, just conditioning vector is injected in conditioning. Yes, this is only difference. Okay, now finally we see the dream boost. So dream boost I will explain by this one example. So suppose we have 3 dog images that share one concept, these images, and we fine-tune the unit. Unit is stable diffusion unit. So unit by these images, and this is text-to-image diffusion model, so we need parallel text. The parallel text is like a V dog, and at this time V is a unique identifier, practically which is set by SKS. Like, anybody knows what is SKS? Yes, that is unique identifier. So thank you. Okay, so problem. Okay, but the problem is language drift. Language drift is like in language models, when large-scale pre-trained model is fine-tuned for specific task or specific few images, the model tends to lose semantic knowledge or generalization of the language. That is language drift problem from language models. And in our case, the Dream Boost model forgets how to generate subject of the same class, like same class is dog, and lose diversity. So when we fine tune by these images, the model tend to generate only these images, even if we input the not a breed dog, just a dog. This is language drift, and surely in my experiments using Dream Boost, I also found that problem. So given set of images like this, the orange background and cute dogs, then generate images by fine-tuned model for the text prompt like a SKS dog with a white background, but model still tends to generate orange background. So this is one of the side effects of language drifting. Of course, Dream Boost authors already know that, so they want to mitigate language drift. So they propose a class-specific prior preservation loss. So this loss is designed to be like this. So using pre-trained model, they generate images for the text or dog, not a breed dog. So when we have generate images, then we fine-tune the unit by these generated images. Same time, as well as we fine-tuned by our given images. So this is a prior preservation loss. So look at the right side. So the top formulation is for fine-tune for the given images, and the bottom side is for prior preservation loss. Okay, this is the end of the dream boost. And another related work is FS scan. So FS scan is actually the few shot adaptation for the generative adversarial networks. So they propose some effective way to adapt GANs in future settings using SVD technique. So when given the weight matrix, they compute singular value decomposition, then becomes like this. And they only fine tune singular value, not the other matrices. That is their technique. Okay, now finally, we can discuss the original paper. So method one is for compact parameter space. So maybe you can remember that. Okay, so one challenge is large parameter space, and we want to make this compact parameter space. Okay, so like FS scan did, we perform SVD on the weight matrices. But actually, the weight matrices are 40 tensors, so we flatten this tensor to 2D matrix and compute SVD. And we optimize the spectral shift delta. Actually, the delta is the difference in the singular value. So then we update the model by optimizing singular value, and the updated weight matrix can be represented like this. So it's just diagonal term, ReLU, and singular value plus spectral shift. This is all. The training loss is also identical to the dream boost. So it is same, but only difference is target parameters. This paper tackles this paper is for only for the singular value, and dream boost trains the all parameters in the unit. Okay, next method is cut mix unmix. This is for the prevent. This is for the preventing the problem is sorry. Okay, the difficulty in learning and representing and generating multiple personalized concepts. So the problem is multiple concepts are unintentionally mixed. To prevent this, they construct training pairs by commix like data augmentation. So when we have target images, they manually cut images and mix them. Then that's all, but the detail is unmixed. So unmixed is like when we have these input, then the cross attention by the panda and left side is maybe high, but the right side should be low or zero because this is not panda. Okay, so this cross attention map, and our regularization term is to reduce the response on the wrong side of the cross attention map. This is a mixed regularization. Okay, this is commix unmix augmentation technique. Okay. 혹시 질문 있으시거나 하면은
언믹스 한 번만 다시 설명해 주시면.
이렇게 언믹스 한국어로 다시 설명을 좀 드리면은 사실 어려운 건 아니고 여기서 이제 포토 오브 V2 스컬프처라고 했는데 여기서 V2가 그 판다예요. 그래서 이 판다에 대한 컨셉을 의미하고 V1 도구에서 이 V1은 이 견종을 의미하도록 지금 학습이 이미 된 상태예요. 그런 상태에서 우리가 여러 퍼스널라이즈드 컨셉에 대해서 대응하게 할 수 있도록 하기 위해서 이렇게 일부러 그 스페이셜하게 잘려져 있는 이미지를 만들고 그렇게 해서 이렇게 텍스트 페어도 같이 만들어요. 이걸 가지고 트레이닝을 할 때 이 텍스트에서 V2에 해당하는 부분이랑 그 다음에 이미지와의 크로스 어텐션을 잴 수가 있을 텐데 이걸 쟀을 때 V2가 판다에 대한 거니까 당연히 이제 레프트 사이드가 높게 나오고 라이트 사이드는 0이 되게 나오는 게 맞는데 이제 그렇게 될 수 있게끔 레귤라이제이션을 걸어주는 거예요. 그게 이제 언믹스 레귤라이제이션입니다.
그러면 저 크롭해서 넣는 건데 오브젝트.
네. 그래서 이제 이 메소드에서 보면 알 수 있듯이 사실 컷 믹서에서 이렇게 만들 수 있는 이미지 종류에는 한계가 있을 수밖에 없잖아요. 그래서 여기서 보여주는 예시들도 대부분 이제 왼쪽 오른쪽 빛이 아니면은 좋게 봤을 때는 위쪽 배경, 아래쪽 오브젝트 이 정도 예시들만 있었고요. 이제 리포트를 보면은 오브젝트 개수가 이제 여러 개 늘어나기 시작하면 잘 안 된다고 하네요. 그렇습니다. 혹시 다른데 또 질문 있으시면은 말씀 주세요. Okay. And they also propose the single image editing. So technique is not that very special, but the only difference is that this technique is performed in their proposed compact parameter space. So when you look at this figure, this is very easy because given the input image and text pair, just fine-tuned by this single image, and the DIM inversion is optional, so we'll skip this, and we edit the text prompt. Then we can edit this image. That's what they said. So this technique is not that very special, but the difference is they use their own parameter space. So why this method is important is that because they said that they tackle the language drifting issue. Actually, when we suffer from language drifting issue, single image editing is very difficult to be done. So they propose this single image editing. Then they can say that they overcome the language drifting limitation. This is their evidence. Okay. The experiments are like this. So single subject, multi-subject, the single image editing is corresponding to the methods what I explained, and several analyses. The single subject generation results is like this. So left column is input images, second is hours, third Dreamboost, fourth LoRa, fifth custom diffusion. And when you look at the results, in my opinion, hours and Dreamboost results are quite similar in terms of quality or the preserving concept. But for LoRa and custom diffusion, their results are, I think, better than LoRa and custom diffusion sometimes. And they also introduce the quantitative results. So look at the right figure. The left axis, y-axis is text alignment, and x-axis is image alignment. But I think that this figure is hard to read because the color means the wallpaper, and the shape of this identifier is some class. So it is hard to analyze, but it seems that Dreamboost and SVDiff quite doing well, but I cannot find what is better than the other somethings. Okay. And multi-subject generation. So multi-subject generation is for the method commix and mix method. Okay. So look at the third law, then the right side is without commix and mix augmentation. In this case, we can see that dog as a sculpture, which is unintentionally mixed concept. But when we use commix and mix augmentation, they are not mixed unintentionally. And they also show single image editing. So look at the red box. Then ours is our compact parameter space, and full means the full parameter space. So we remove a picture on the wall, but in the case of full parameter space, picture remains. So they said this is the difference of the compact parameter space and full parameter space. So by showing this, they said that they overcome the limitation of language drift issue. And analysis, this is weight combination. So when we fine tune the different delta, which is for specific concept, and just combine them, then results are like this. So their concepts are combined properly, but sometimes it's not. So the dog and sculpture are mixed. So this shows the difficulty in multiple concept generation. So this is the reason they propose commix and mix augmentation. And next is style transfer and mixing. The style transfer is actually just editing text as you want, and they said that it shows quite nice results, but not that perfect. And style mixing is actually, this method is from the other work, so they just say that their parameter space is also can be extended to the other method from the other paper. Okay. And this is interpolation examples. So the alpha is the interpolation vector. So we can see that they quite interpolate well. Okay. Before we move on conclusion, anybody has a question?
질문이 있는데 멀티플 오브젝트를 질문해서 그래서 뭔가 이런 케이스에서만 될 것 같은 느낌이 들더라고요. 이제 텍스트는 이제 비사이드로만 고정돼 있고 뭐 다른 이미지들 크롭돼서 옆에만 이렇게 붙여서 딱 저 케이스만 될 것 같은데 혹시 다른 뭐 퀄리테이티브 리절트가 있었는지 뭐 어버브 하면은 위아래로 붙여서 된다든지 아니면 아예 이런 크롭 관계랑 좀 무관하게도 저렇게 됐는지가 궁금합니다. 다른 퀄리테이티브 리절트가 있는지.
그게 없진 않은데 아까 말했던 것처럼 그 위아래에 그 원경 백그라운드랑 포어그라운드가 있는 형태는 이제 얘네들이 보여줬습니다. 근데 이제 그런 정도를 넘어서는 뭔가 이제 다양한 조합이 있을 수가 있잖아요. 꼭 이렇게 공간이 분리가 안 되고 사실은 뭐 사람이 선글라스를 쓰고 있다던가 이런 것도 다 컨셉트를 합치는 거에 해당할 텐데 그런 거는 이제 전혀 다룰 수가 없는 구조인 것 같아요. 이게 이걸 다루는 것 자체가 이제 컴믹스 언믹스로 하는 건데 그 방식에서는 다룰 수 없는 구조들은 아예 다룰 수가 없는 것 같고 그리고 이런 구조더라도 이제 이런 컨셉트의 개수가 늘어나기 시작하면 잘 안 된다라고 리포트를 했어요. 그렇습니다. 질문 없으면 conclusion 하겠습니다. So the conclusion is like this. They propose a compact parameter space using the SVD technique, and they show similar or better results compared to full rate fine-tuning in both single and multi-subjects generation. Their commix unmix technique clearly improves multi-subject generation, but it has many limitations. And yes, and spectral shift is actually the compact parameter space. So this serves as a regularization. So this enables single image editing. And they said that there could be a potential research like combining this work and Aurora. And they also say the limitations. Commix unmix does not perform well when more subjects are added, like Wonjun asked. And single image editing can preserve background unintentionally, inadequately. But this is the limitations. Okay. That's the end of my presentation. Thanks for listening.